Hey math fans, welcome to the video over converting standard form quadratic equations into vertex form. Okay, so what we're going to do is we're going to have an equation that looks something like this. This is standard form, ax squared plus bx plus c, and then we're going to convert it into looking like this in vertex form. Okay, um, and so, on the topic of vertex form, it's important to note that your h and your k form the coordinates of your vertex. That's the whole reason why it's called vertex form, is because you can see the coordinates of the vertex in the equation. Okay, and also when an equation's in vertex form, your teacher might ask you questions about the transformations or the domain and the range. It's just a lot easier to tell that information from a vertex form equation um, when compared to a standard form quadratic equation. Okay, so the h is your x coordinate of the vertex, right? And the formula says x minus h, so you're going to have to flip that sign, okay? And on the topic of h, we have this. The axis of symmetry, x equals negative b over 2a, okay? The reason why I say on the topic of h is because the axis of symmetry is always the x coordinate of your vertex. So you can think of it like this. You can think of it as h equals negative b over 2a, because that's going to help us find our x coordinate of our vertex. Okay, it's going to be that, it's going to end up being that number. All right. And then how we'll get the k is, well, I'll get to it, but we'll get that h value and we'll plug it back into the original equation. Okay, so this axis of symmetry formula, it's only to be used for equations that are in standard form. Okay, so I have an equation here, f of x equals negative x squared minus 2x plus 1. That's already in standard form. As long as everything is on one side of the equal sign and in order, meaning it starts with something x squared, then something x, then a constant term, then you know it's in standard form. Okay, so before I proceed, I like to label my a values. This is a negative x squared, right? So it's like negative 1x squared. That means my a is negative 1. I don't write the x squared with it, okay? It's just the coefficient by the x squared. And so b is the coefficient by the x. So I'm going to say b is negative 2. And c is your constant term, which is plus 1. So I'm just going to write a positive 1, okay? And so those are my a, b, and c values. So when I do my axis of symmetry, that says x equals negative b over 2a. I'm going to say x equals, well, if it says negative b and b is already negative, then it'll turn positive. So I'll go positive 2 over, and then 2a. So that means 2 times your a value. Your a value is negative 1. Okay, so this is 2 over, 2 times negative 1 is negative 2. So 2 over negative 2, that's going to make negative 1. So I have an axis of symmetry at x equals negative 1. Okay, um, so in other words, that's your h value. Okay, that's also your h value. So all that information just comes from that right there. Okay, what you're going to do is you're going to take that negative 1 and you're going to plug it in for x into your function. Okay, and so remember, f of x is interchangeable with y. So instead of saying f of x equals, I'll say y equals, and I'll go negative, and then I'll plug in for x squared, right? X squared was negative 1. Okay, and then it says minus 2x. And so, again, I'm replacing x with that negative 1, and then plus 1. Okay, so you can type this into a calculator, just don't type in the y equals part. Um, But negative 1 squared is positive 1, but it's got a negative on the outside. So this is negative 1. This becomes plus 2. So negative 1 plus 2 is 1. 1 plus 1 is 2. So this says y equals 2. And we call this our min or max value, okay? And it's actually going to be a maximum. And the reason why I can tell it's a maximum is because of that a value, okay? That a value determines whether the graph opens up or down. Because no matter what, you're going to have a parabola when you have an x squared term. So it's either going to look something like this, one of these two options, okay? So when a is positive, it'll open up. When a is negative, it'll open down, okay? That leading coefficient determines the behavior of the graph. So I'm going to say that this opens down, putting the vertex at the top, creating a maximum value, okay? So y equals 2 is my maximum value. And by the way, your maximum value, that's your y coordinate of your vertex. If that's the y coordinate of your vertex, then that's your k value, okay? So, since we know our h value is negative 1 and our k value is 2, the vertex form uses h and k. We just need to figure out what that a value is. Well, guess what? There's an a here. That's the same a, okay? So you can use that same a, well, you have to use that same a that you had from the standard form. So I'm going to use negative 1 in my new function, okay? So I rewrote my formula, y equals a times x minus h squared plus k, just so you can see what I'm plugging in. You always leave the x and the y behind, okay? So y equals a is negative 1, x minus h, so x and then minus h. If I'm minusing a negative 1, then it turns into plus 1, okay? So let me just write minus negative 1. And then plus k, let's see here, plus k is 2, so plus 2, okay? So minusing negative 1 turns into plus 1. So you can kind of skip this step and you can just write x plus 1 squared plus 2. And then if we have a negative 1 for our a value, you typically just see it as a negative, not a negative 1, okay? And then if you want to be fancy, again, they're interchangeable. You can say y equals, or if you want to be fancy, you can say f of x equals, okay? But this would be the final answer here, okay? It tells us our vertex, all right? And it's the same equation. We just converted it from standard form to vertex form. How you would check this would be to graph it, just to see if they overlap. So what I did was I went ahead and I graphed this into Desmos here. And you can see here's the original graph, and then, or the original function, I should say, in standard form. And here's my equation in vertex form. And you can see that there's only one graph here. That's because they perfectly overlap. And then they have the same vertex. Remember, we had an h value of negative 1 and a k value of 2. So that puts my vertex at negative 1, 2. And so, yeah, that's pretty much everything to say about that one. So let's do one more example here. Here I have an equation, 3x squared plus 6x plus 5. So I'm going to start this off and I'm going to say, hey, a is 3 because a is the value by x squared, b is the value by x, so b is 6, and c is the constant value, not by any letters, so c is 5. And so since we know that a is a positive 3, if a is positive, that means our graph will open upwards, putting our vertex at the bottom, creating a minimum value. Okay, so we'll talk about that in a second, but it's just good to know that, hey, we're going to have a graph that opens up. Okay, so what we're going to do next is we're going to do our axis of symmetry formula. Our axis of symmetry was x equals negative b over 2a. Okay, so we're going to say x equals, and so we had positive 6, so I'm going to write negative 6 over 2a, so 2 times 3. Okay, so 2 times 3 is 6, so this says what's negative 6 over 6. So coincidentally enough, this is going to be x equals negative 1, just like the last one. Okay, and so that's where our axis of symmetry is. So I didn't point it out with the last one, but the axis of symmetry, that is your imaginary line that splits the graph in half. Okay, so that's basically what the axis of symmetry means. Okay, so that's what's going on this one as well, and I can redraw that when I show you the graph at the end. But in the meantime, what this tells us is our h value. It tells us that h equals negative 1, okay? And we just need to find that k value. So to find that k value, we're going to take that negative 1 and we're going to plug it in for x. So we're going to say y equals 3 times negative 1 squared plus 6 times negative 1 plus 5, okay? So 3 times negative 1 squared, that's going to be, this is going to make positive 1 times 3 is 3. This is going to make negative 6, so 3 minus 6 is negative 3. Negative 3 plus 5 is 2. So this says y equals 2, okay? That's also telling us our k value of our vertex, okay? Our k value is 2, and as I mentioned earlier, that's a minimum value, okay? So we know that h is negative 1 and k is positive 2. That means we have a vertex at negative 1, positive 2, okay? So how are we going to write our converted equation into vertex form? Um, Again, you can use f of x equals or y equals. It's the same thing. I'm just going to use f of x equals because that's how the function started off as. And so we're going to use our a value, which is 3. Okay, so f of x equals 3, and then you go parentheses x minus h. So if it says x minus h and h was negative 1, I'm minusing a negative 1. So instead of writing minus negative 1, I'm going to turn that into a plus 1. Okay, and then that's going to have a little power 2 on the outside, and then it'll say plus 2. All right, so that's our equation in vertex form. If we want to check this, we can graph it and make sure they overlap. So here I have my graph. I have the original form and standard form, and then the vertex form. It makes one graph just as it should. Because when you convert it, you're not really changing the appearance of the graph, you're just changing the appearance of the equation. You can see that they have the same vertex at negative 1, 2. It's coincidentally enough the same vertex as the first one. And as I said before, that axis of symmetry, that is just an imaginary line that would split the graph in half, okay? But yeah, that's pretty much everything there is to say about this. Just to kind of recap, you need to do your axis of symmetry formula first, and then you need to get that value and plug it into your equation. And once you have to get a y value, okay, once you get the x and the y value, just reuse that a value and you have your vertex form. So with that being said, thanks for watching. Hope you learned something, and goodbye.